Hi all. In this video, I will going to discuss core building blocks of LangGraph. If you are aware on this building block, you can create complex AI agentic system without any hassle. Before discussing this, first we will look at why we need LangGraph. When you design an AI system, probably you could have user prompt LLM response. This is perfectly fine. But some scenario, we need previous information. So calling LLM alongs, you couldn't able to achieve this. The next scenario, sometimes we need to have up-to-date data. So like weather report and stock price changes, those kind of up-to-date data, we couldn't able to get it from the LLM. The next scenario, sometimes we have to take a decision. According to the situation, we have to take a decision. And the next scenario, sometimes we have to call multiple steps to get the response. And some failure scenario, we have to do the retry. So those kind of complex scenario, we couldn't able to achieve using the LLM. That's why we need LangGraph framework. Hope you guys are clear on this. Okay, now we will look at what are the core building blocks of LangGraph. There are three main building blocks. One is state, other one is node, and other one is a graph. These are the main three building block of LangGraph. Okay, first we will discuss the state. Let's discuss this example. When you go to hospital as a patient, first you have to do the registration. Once you done the registration, they will create the patient record for you. Then once you visit the doctor, so the doctor will look at your patient record, and after observing you, he will update the same patient record. Then probably you need to go to the lab. From the technician, he will look at the same patient record. After taking the lab reports, he will update the same patient record. Probably next you have to go to the pharmacist. Then the pharmacist look at your patient record. According to the prescription, he will provide the medicine for you. So in that case, your patient record will share among the each department. Likewise, in state, we will share the updated detail across the nodes. Hope you guys are clear on this. We will discuss the nodes. Why we need nodes? So let's say when you design a complex agentic AI system, probably you have multiple tasks to execute. So in that case, you can create each node to execute tasks one by one. Then you should have multiple nodes. Hope you guys are clear on this. Then you can create the multiple nodes, and each node you can have each task. So likewise, you can have a multiple node for the each task. Hope you guys are clear on this. Now we go to the graphs. Why we need graph? Graph will use to interconnect those nodes and provide the correct workflow to execute our system. Hope you guys are clear on these three steps. Then we will look at the example. From there, we'll discuss more. Okay, we'll jump to the example. Take a look at this example. First, create the folder. So inside the folder, we need to create the virtual environment. So for that, we can create the virtual environment. We'll create that first. Okay, we'll create the virtual environment. So then you have to activate this virtual environment. So we will activate this. Okay, next you need to install LangGraph. Okay, we will install the LangGraph. You can see now it's activated. Now we are inside the virtual environment, so we'll create the LangGraph. Install the LangGraph. Okay, so now we will create the notebook. I will create the notebook here. LangGraph example 1 I. Okay, this is the our notebook. Okay, we need to import type dictionary and the state graph. We need to import these libraries first. Okay, next we need to define the state. Okay, see how we define the state. This is the state. This is how we define the state. Next we can have a node. Okay, this is our first node. Inside the first node, so we have a message. We'll update the state message. We'll update the state message hi with the input value with name. Okay, so then we'll compile it. Then we will create the next node. Then here the next node we will update the same state message to welcome to the LangGraph example. So we will update the same state message. Hope you guys are clear on this. Then so you can see we are sharing the same state, and in that each nodes we are updating the same state message. You can see it here. Hope you guys are clear on this. Then next thing, so then we have state here. So then we have node here. So we have two core building blocks here, state and the node. Now we need to have graph. So let's see how we define the graph. This is how we define the graph. Then we have to define the each node. What are the node we have in our application? We have to define here. This is how we are defining the node. Okay, so now we need to connect each graph, each node one by one. Let's see how we going to connect each graph one by one. First we need to have a start node. First we need to define the start node. So this is how we are defining the connecting the graph. First edge we are starting edge. So then first node will connect as a start edge. Okay, next we have to define the next connection node. So then we will first call the node 1, then it will next we will call the node 2. So likewise second node. First call the first node and later we'll call the second node. Then we have to define carefully these edges. First we have to call the first node, then we have to call the second node. Okay, hope you are clear. Then we don't have any other nodes, so then we can end this graph like this. Then we have to compile this graph. So let's see how we compile this graph. This is how we compiling this graph. Okay, so now we have all the core building blocks of LangGraph. So we have state and we have nodes and we have graph here. So now our application is completed. So now we will see the output. First we will see how graph look like in our application. This is a basic graph, so it's a sequence graph. So we'll run this application. See, you can see the combined output. So that's how the state share the detail among the application, and here you can see the output. So we can have combined output connecting all the nodes. Okay, now we will see the output. So you can see Okay, now you can see the output. So we have node 1 result and the node 2 result together as a output. So that's where that state will share the updated detail among the node, and here the graph will connecting each node accordingly. So then we can get it the combined result as output. So hope you guys are clear on this video. If you have any doubts, please uh, put the comment in comment section so I can address all those comments. In the next video, I will going to create the simple chat application, and I will show it to you how to maintain the previous chat history from that chat application. Okay, thanks all.